All right, so get this. Today's deep dive is going to take us like straight into the quantum realm, you know?
Oh, yeah.
We're talking entanglement.
Okay.
That spooky action at a distance thing that even Einstein couldn't really wrap his head around.
Yeah.
But here's the thing. AI might have just cracked the code on making it way simpler than scientists ever thought possible.
Yeah, what's fascinating here is that we're not just talking theoretical physics anymore.
Right.
This is like, this breakthrough could have real-world implications for things like, quantum computing and ultra-secure communication.
Yeah, and that's what we're going to be diving into today.
Yeah, let's get into it.
We're basing this deep dive on a recent article from space.com about this discovery.
Oh, cool.
And let me tell you, it's a wild ride.
Yeah.
So are you ready to untangle this mystery with me?
Absolutely. Let's dive in.
Okay, so you already know the basics of entanglement, right?
Yeah.
Two particles get so close they basically become best friends for life,
Right.
sharing properties no matter how far apart they are. It's like they have this secret instantaneous communication channel.
Yeah.
But creating that entanglement, that's been the real headache, hasn't it?
Yeah, traditionally it's involved creating multiple entangled pairs.
Right?
And then using this complex measurement called a Bell state measurement
Oh, wow.
to force the particles to entangle.
So not exactly a walk in the park.
Yeah.
And this is where our AI friend comes in.
Okay.
The researchers were using this AI called Pythias.
Pythias.
Yeah, designed specifically for quantum experiments to try and reproduce these traditional entanglement methods, but Pythias kept suggesting a much simpler way. So what happened?
Well, the scientists were initially skeptical, of course.
Really?
I mean, can you imagine an AI telling a bunch of physicists how to do their jobs?
Yeah.
Especially in a field as complex as quantum mechanics.
Right, I'd be raising an eyebrow too.
Totally.
So what was this revolutionary idea that Pythias came up with?
Well, Pythias pointed out that the key to simpler entanglement lies in making the paths of the photons, those tiny particles of light, indistinguishable.
Oh, okay.
It's like having two identical twins walking down separate hallways.
Okay.
If you only see one emerge at the end, you can't be sure which twin it was.
Right.
This uncertainty, this indistinguishability is what Pythias suggested would lead to entanglement.
Hold on, I need to wrap my head around this.
Sure.
So you're telling me that by simply making it impossible to tell which path a photon took, we can entangle them?
That's exactly what Pythias proposed.
No.
And the researchers, despite their initial doubts, decided to put it to the test.
Wait, so they actually tested this crazy idea?
They did.
I'm on the edge of my seat here. Did it work?
Amazingly, yes.
No way.
By simply controlling the paths of the photons and making them indistinguishable, entanglement emerged spontaneously.
Wow.
They were able to bypass all those complex Bell state measurements and create entanglement in a much simpler way.
That's wild. So the AI basically found a shortcut through a jungle of complex physics.
That's one way to put it.
This is huge, but what does it actually mean for the future of quantum tech?
Well, this simpler method of entanglement could revolutionize how we build quantum networks.
Okay.
Imagine a world with ultra-secure communication, where it's physically impossible to intercept a message.
Oh, wow.
That could become a reality much sooner than we thought.
So we could be one step closer to a quantum internet, all thanks to this AI.
It's definitely a possibility.
I can already see the headlines, AI outsmarts physicists, unlocks quantum future.
Yeah.
But didn't the article mention something about a physicist from CERN?
Yes. Sofia Vallecorsa, a physicist at CERN, was quoted as saying, "The more we can rely on simple technology, the more we can increase the range of applications." This discovery has the potential to make quantum technologies much more practical and accessible.
That's incredibly exciting, but I'm also wondering, is everyone in the scientific community as enthusiastic about this AI breakthrough?
Well, there are always some reservations when a new technology enters the scene, especially one as powerful as AI.
Right.
Some scientists worry that we might become overly reliant on AI accepting its answers without fully understanding the why behind them.
Yeah, that makes sense. It's like using a calculator without understanding the underlying math. You might get the right answer, but you wouldn't truly grasp the concept.
Exactly.
Okay.
But this study is a compelling example of how AI can be used responsibly as a partner in scientific exploration.
Right.
It's not about replacing human ingenuity, but about enhancing it.
So it's a collaboration, a synergy between human intelligence and artificial intelligence.
Precisely.
But let's not get ahead of ourselves. We've talked about the potential, but what about the challenges?
Well, one of the biggest challenges in quantum mechanics is dealing with something called noise.
Noise.
Imagine you're trying to build a house of cards in a hurricane.
Oh my God.
That's kind of what it's like trying to maintain the delicate balance of a quantum system in the real world.
Yeah.
Even the slightest disturbance can disrupt those delicate quantum states and cause errors.
Okay. I'm starting to see why building practical quantum technologies is so tricky. So, how are scientists trying to overcome this noise problem?
One approach is to develop error correction codes, specifically designed for quantum systems.
Okay.
These codes act like a safety net, allowing the system to detect and correct errors caused by noise.
Huh. Interesting.
Think of it like a spell checker for quantum computations.
That's a pretty neat analogy. So, even with these challenges, it sounds like we're moving in the right direction.
We are.
I can't wait to see what other breakthroughs are just around the corner.
I agree. This discovery with Pythias has opened up some truly exciting possibilities.
Yeah.
It's a testament to the power of human curiosity, scientific ingenuity, and the potential of AI to accelerate our understanding of the universe.
But let's not forget, this is just the beginning of our deep dive. We've explored the basics of entanglement, the AI's groundbreaking role, and some of the challenges ahead.
Right.
But there's still so much more to uncover.
Absolutely. In the next part, we'll delve deeper into the potential applications of this simplified entanglement, exploring how it could revolutionize fields beyond physics, from medicine to material science.
And we'll also be looking at the wider societal and ethical implications of this quantum revolution. So buckle up because things are about to get even more interesting.
Oh, yeah.
We'll see you next time.
See you then.